Hello, everybody, and welcome back. Good to see so many people coming in. Hello, hello. If you're here and ready to go, hello, good night. Feel free to drop a little message in the chat while I introduce our speaker for today and get them on the stage. Today we have Massimo from Subsquid, who will be talking about how to combine Substrate and EVM indexing. And while Massimo is coming to the stage, please feel free to follow them on Twitter. Follow Massimo on Twitter here at Raekwon and also Subsquid. I've dropped those links in the chat. And yeah, it's good to see people coming in still. Okay, so whenever you are ready, Massimo, feel free.
Okay, yeah, thank you for having me, first of all, and thank you for hosting Subsquid as a project. Okay, you should be seeing infinite screens right now. So I'm going to switch to the presentation. And yeah, I don't know if you're still there, Angela, but thank you for the introduction.
No problem.
So the purpose of today's, or the subject of today's workshop is how to combine EVM and substrate data with Subsquid. And I made a funny subtitle, one framework to index them all. The idea is, first of all, let's introduce Angela has already made the introduction. My name is Massimo Luraschi. I'm a developer advocate at Subsquid. She will drop the links, but this is my Twitter handle. It's 3 uppercase I's, not 3 L's. And like similarly, all the other sources are here. But what is an indexing middleware, first of all, and why would you care about it? So the idea is that data is stored on a blockchain, and blockchain is an amazing tool, an amazing technology to securely store data and to make sure that it's not being tampered with, so that nobody touched it after it was written, right? Because given the history of the blockchain, you cannot go back and change it, otherwise the rest of the chain will just have a domino effect, basically. But it's not the best tool when you want to extract it, when you want to extract this data and use it. For example, if you want to build a nice front end based off of the data stored on the blockchain. It's not ideal. It's not how actually all of the front ends that already are present for decentralized dApps are built. They usually have an indexing middleware, which, as the name says, stands in the middle. It's used to prefetch, do some data manipulation like aggregations or simple like typings conversions, and most of all, filtering of the data to store exactly what you need, how you need it, and make it much easier to query. Here we have an example. On the blockchain, we only have transactions, right? And those are not useful if I want to find the NFT that Alice owns, right? But if you put an indexing middleware, it will have data stored in such a way that with a nice API, you can just answer this question directly. And in your front end, in your, say, marketplace, you can store all of the NFTs that Alice owned. And so this is how it works. In our case, we ingest the data first, and then we provide a data processing framework for you to build this thing right here. So, like I said, why would you Why would you use an indexing middleware, and why it's important? First of all, it minimizes the network requests, and it minimizes also the network storage. The required storage, because you would only store the data that you decided that you need, not the entire blockchain. Nobody has to have an entire duplicate of the blockchain. You would filter it down. And you can also easily seamlessly update. And because of the way we built it, it's also inherently multi-chain because we have what I'm going to introduce in a second, archives for every, most chains out there. Definitely pretty much every Polkadot, every Substrate chain, but also every EVM. And these are 2 concepts that I'm going to talk about a lot in this presentation, and I'm going to also explain what it is. are. I explained the architecture, but I mentioned the architecture, but actually let me explain it a little bit further. This is how we imagine, you can imagine what this chart sort of depicts is a pipeline. It's commonly used as a term in information technology because, well, it's kind of like pipings in your house. You basically let the data pass through this pipe, and while it passes through, there's certain actions being applied to it. So you have the blockchain, and in this data pipeline, we first of all store it, ingest it, with some minimal processing to make it easy to be post-processed. And this is where actually the customization and the personalization and the development takes place, where you just say, okay, I only need the NFTs from this collection, and so I only requesting data for them, and I'm also like aggregating them by establishing a link to their owner, so that I can just get the owner persona and find out all of the NFTs that it owns, for example. And this stage is the most important one because different ways in way you implement this lead to different, for example, use cases. Moving forward, one of the greatest difference in the approach of Subsquid is this kind of architecture, where we split it into two stages, the initial ingestion and the customization, because some similar framework only do don't do the decoupling of these two stages. And so you would have your indexer, which has the customization that you want to build on top, but has to do all the ingestion by itself. And this is obviously a waste of performance, a waste of effort. Ultimately, it will be costlier to maintain because of the wasted resources. And in short, it's inefficient, right? So to better drill down of how this works, like I said, the archive, which is the ingestion stage that we take care of, you don't have to care about, does this. It does the pre-ingestion. It stores the data in a very carefully designed for this particular task database. It's, in our case, it's a distributed database, but other, like the second generation of our archives, is actually using more performant means of storage, such as Parquet files. And then it serves through an API. It can be a GraphQL server in the case of Substrate archives, but in the second generation, it's actually just a normal RESTful API. But this is the difference, because if you were to connect your dApp directly to the blockchain, you would have to go through direct RPC connection to the blockchain, which are not ideal, not because of the connection itself, but because of like the kind of data that you would have to request. And then this is the Squid, which is the customization part. We're going to see it in a second, but this is where you apply your custom logic. And this is the sort of connection where blockchain gets ingested, stored, all of the data is there, but it's stored in such a way that it's easier to filter and do specific queries to the data. And then this is where you actually use it. But one single archive can serve multiple squids. And this is sort of like the innovation in it, where the data ingestion, which is the sort of doing the heavy lifting for you, does not have to be replicated. It's just one, and it's serving multiple squids. Well, I mentioned already some of these benefits. It's just one less thing that you have to care about, because we take care of it, and this is the part that's going to be decentralized ultimately. And because of this decoupling, one of the advantages is the modularity. Like I said, it's already being improved upon, and it will just get better. But the framework essentially stayed the same, right? It improved in a separate way. It reduces network overhead, like a lot of the stuff I already mentioned. One thing that I didn't, and it's quite important, is that one of the differences between this connection and this one is that we designed this API server to provide data in batches. so that you would not have to have like one single request to get one single transaction, but you would just have one single request, and you can require a batch of transactions, and then you process them on your own so that the network overhead is reduced. And this is the other part. It's quite similar in design, but has essential differences in the components. So in our case, the database is going to be a Postgres database, just a standard issue, but you can swap it for whatever you want. I have examples of a different storage where I save data in a CSV file, in a Parquet file. I even save it in a Parquet file and store it on an S3 bucket in the cloud. This is where the actual customization happens. And this is what we're going to build in the second part of the workshop, where we get practical with it. The benefit of the Subsquid SDK is that we try to make life easier for the developers. We automate a lot of the stuff. For example, given a certain ABI, we generate a Typescript code that essentially acts as a wrapper around it, and you can just poke the contract, use it to decode EVM logs and transactions. And the second thing, for me, it's an advantage because it gives you more power, is that similar toolkits just let you specify the customization in a configuration file. While because our project, your Squid, is going to be a Node.js project, so you code in TypeScript, and this gives you a lot more freedom, a lot more flexibility. The power is up to you, essentially. And like I mentioned already, we're going to code in TypeScript, and one of the advantages is that it provides strong typings, so that you're not going to incur in weird errors where you're going to extract an integer of some certain shape, and you're actually going to try and place it in a float on the database, and the database is not going to be happy. We take care of this thanks to these two steps. The automation that we put in place will make sure that for a certain contract, we know the typings. So we're going to generate TypeScript classes and functions that are going to take care of the typings for you. And lastly, to make things even easier, you don't have to take care of deployment. We have our hosting service that, if you want to, your final result, your project, you can just push it and deploy to what we call Aquarium, because squids swim in the aquarium. And there you can have your API live and publicly available. To talk a little bit more in practice, what I mean by automation is that you can specify the schema and define the entity, in this case, an owner, which has an ID, how many tokens does it own, what's the balance in terms of, for example, this could be NFTs, but this could be the balance of their wallet in terms of ERC20 tokens. And this class is going to be generated automatically for you. As you can see, it respects the name, the fields, which are the fields of the schema, the columns, essentially on the database. And it knows how to tie together the types and link together different entities. And similarly, from contract ABI, when you have, for example, in this case, it's a function. When you have this function which is named approve, and it has these inputs, we generate automatically the TypeScript sort of corresponding function for it. We have defined a class which wraps the concept of a smart contract function, and it respects the typings, and it also exposes a function to decode it. So that way I can just get the input. This comes from the blockchain. And then I can say, well, what was the input of this function? And then I can have in this case, this is the wrong argument, but I can have the address of the person that was approved to move this token, for example. I mentioned the Aquarium Hosting, and this is literally how you can deploy your Squid. Once you build it, you should have already installed the command line library, and just with one command, you will have your API deployed on Aquarium, and you can visit this link. I think. Let me check. Yes, there it is. So in this case, this is my account, and here I have a few squids. One of this is me indexing Ethereum nature, and I can see that this is the API, and I can poke it around and play with it and request data. It's a little bit too zoomed in. I realize that my screen is quite big, so usually in meetings people complain. But let's move forward. There's many resources available for developers who want to learn. First of all, the docs, of course. With every project, the first place where you go and take a look, it's the docs. But we also have we're an open source project, so everything is there. You can just browse around the repository and take a look. And I personally created some educational material that is available on YouTube and on Medium. There's articles there that sort of go through like small tutorials with usually a very specific topic. Like I mentioned, storing data on a CSV instead of a database, or for example, index the Ethereum name service project, and so on and so forth. But let's get coding. Let's start. So I'm going to switch back and forth between the presentation and my coding environment. Let's start with what we're going to build. As you know, maybe some of you, and this is where I introduce a little bit of the concept, Moonbeam is a very particular blockchain because it's a substrate blockchain, which is a parachain of Polkadot. And Substrate is the underlying technology, the framework that allowed Moonbeam developers to build the blockchain. It has its own sort of specifics, such as the fact that when you trigger part of the logic, you actually call a function, and when that happens, usually the code triggers an event, for example. And this is what we index with Subsquid. In contrast, as you may know, Ethereum is a different kind of blockchain, and the execution of logic from the blockchain is dictated by the Ethereum virtual machine, for short EVM. Moonbeam is peculiar because even though it's built on Substrate, it has a palette, which is sort of like a module, a subcomponent of the whole Substrate logic that runs on Moonbeam. This palette is called EVM, and it's able to run smart contracts that were developed for Ethereum, for example. So it's basically Ethereum plus Substrate, if you want to think about it in very simple terms. And so what I'm going to show you today with this project is how you can have the best of both worlds, because you can index both sides in one single project. And the way I'm going to show it to you is that I'm going to index transactions of the USDT token, which is an ERC20 token written as a smart contract for the Ethereum virtual machine. And also you can index Glimmer, which is the native token. And this is actually the logic for this is running on Substrate. So we're going to go through all of these steps. We start with the basic setup. We change the schema to accommodate our needs and capture the entities, and which essentially translates to tables on the database. Then we automatically generate Substrate types. We go and grab the contract API for the USDT smart contract, and then we go edit the logic in the processor, finally launch the database, and then just profit, essentially. So let's get started. The only requisites are Node.js, a Docker, and the Subsquid command line library, which I already showed you how to install. It's npm i at subsquid/CLI. And with that, I can just literally go on a terminal. Nope, not this one. SQD, encode, live. I forgot image. This is why I copy and don't type. It provides you with a list of templates, and they're for different kind of chains, different kind of projects. EVM is the basic project for Ethereum. These are a couple of examples. Substrate is for pure substrate chains. In this case, we're going to use Frontier EVM because Frontier is the people who have built this module for substrate chains. And as you can see, it's indexing Frontier EVM chains like Moonbeam and Astar. So we're going to start with that. And now we have in the Encode Live library, I'm going to install the dependencies and open the project. So open them, Encode. Oh, no, I forgot. Well, it's not in the right folder, but it doesn't matter. So this is how a basic project looks like. We have a few components here, and we're going to go through all of them as we start developing. The first thing that we're going to take a look at is the schema. This is how the project comes with. It's already like potentially I could launch it already, and it's doing it's performing the logic that it was built with, and we're going to just make a few changes to adapt it to what I want to do today. In this case, I think it's indexing NFTs, so that's why you have tokens and transfers of tokens, and the owner that owns a certain number of these, and etc. So what we are going to do is change the owner to have different balances. We're going to keep them separate. And then we're going to change the transfers to have not the tokens, but the amount that was exchanged. Right, and I think we don't need this, and well, of course we don't need this. We should be good. So we remove the token entity and we change the owner transfer. And when it comes to generation, we're gonna hit this magic command, and I'm gonna show you the result really quickly. A few changes have been made in this source model generated folder, where we have models that represent this schema that we just made. So if we take a look at the owner, it's similar to what I showed you in the presentation before. It's just adapted to the schema that we just made. Now, for Substrate event, we have a nice little thing where we essentially are going to request the information about the blockchain itself to the archive. And the archive is going to tell us the evolution of this specific event and this specific storage. Storage is a different concept, like an additional concept that maybe it's better if I introduce it. Whenever a transaction is submitted to the blockchain, it changes the state of what it's interacting with. Let's say it's changing. Let's say I'm transferring a certain balance. I'm changing the balance of a certain account. And so the blockchain does not just store the fact that a transaction was submitted in the form of an event. It also stores the status constantly, and it updates, right? And so what I can do is I can also require what was the status of this account at a certain time. This is usually a very costly operation because I cannot do it via the archive. I have to go through the blockchain. Only the blockchain has this status. So usually it's discouraged, but I want to show you how you could potentially do it should you need to. And so these sort of the event and the storage can be written in different ways because one of the peculiar things about Substrate is that the blockchain can update itself, can be updated. So let's say I want to change the logic, I want to change the types of a certain event. I can do it by just propagating the update, and every node is going to just update itself. But from that point on, the transfer event, for example, is going to be written in a different way. And so we have to know it if we want to index it. And our archives do know it, right? So let's open up this typegen configuration file. First of all, we need to change the archive because we're not indexing Moonriver, we're indexing Moonbeam today. Then we can specify that we want to know the history of balances transfer event, and also this storage. This is just for a bonus thing I might have time to do at the end. Besides from the fact that you can query the storage, you could ignore it for now. And then the one thing that I want to show you as well is that the SDK comes with its own sort of command line shortcuts in the form of this JSON file that has configurations for these shortcuts. And by doing this, we're just going to add a new one for my own convenience, because I never remember the right syntax, and it's just easier to, for example, run cogent like I did, rather than remember that it's squid type or cogent. So I can do this right now, and then I can run std type again substrate. And what this is going to do is, as the log says, it's reading the configuration file, downloading the spec version for Moonbeam, and then it has produced these files right here. So it has created an event class for the event that I specified. And in this case, it knows that on runtime version, which is the updates that have been done to Moonbeam, on runtime version number 900, this event was changed to look like this. And instead, after runtime version number 12,001, it changed to this. So it's essentially the same information, just represented in a different way. Previously, it was an array, now it's an object. Moving on, we can take a look at the USDT contract. And well, it doesn't matter. This is Moonscan, which is a useful tool. I use it all the time. You can just search for every contract, and it tells you the name of the contract and all of the information, the transfers, etc. But obviously, it's not useful if you want to do your build your own website, right? What I use it for is to go to the contract tab right here and go to the contract ABI, which is the ABI stands for Abstract Binary Interface, because of course, when the contract is deployed on chain, it's just an executable, it's binary. No one knows exactly how to read it apart from the computer. So if you want to interact with it, you have to have a description of the interface. So what kind of data do I have to provide it with, and what kind of data it will give me back in return? And this is exactly what the ABI does for me. It's a description of the interface of the contract. So I can copy it in.
Massimo,
Hello?
so,
Yep.
Are you able to zoom in a tiny bit more?
Yes. Like this? Or like on the page or on the code?
Guys, type in the chat what you'd like. I think we're saying bigger font.
Okay. Yeah, I don't know. I hope this works, and I'll do it as well for the code.
Thank you so much.
Should be good. Yeah, like I said, it's always an issue, and I never know how much it's needed. And once I copied the ABI, I'm gonna paste it into a file in here, and I'm just gonna name it usdt.json. That's it, and let's format it a little bit better. So as I mentioned, this is, for example, a function named, which is called withdraw vault, and it needs these inputs, for example. For today, we're gonna take a look at the transfer, this event right here, which is triggered every time the coin, the token, is transferred, and it's telling me who transferred it, to who, and how much, which is exactly what I need. Now I've made a mess. Okay, that's good. So yeah, like I said, we went to Moonscan, we got the ABI, we pasted it into a JSON, and then what's missing is we launched this command again, which is similar to what we just did for Substrate. This is the counterpart for EVM smart contract. It's going to take a look at the ABI, and it's going to generate TypeScript code that allows me to interact with it. The dash multicall, it's a shortcut. I don't know if I have time to look into it at the end of the workshop. Oh yeah, not bad. API slash. So what it has generated for me is in this folder. As you can see, it says source API, blah, blah, blah. And what I'm actually interested in is this file right here. And let me close the terminal for a second. It has generated a series of these events right here. And they represent exactly what's represented here. So if you take a look at transfer, this is sort of like the TypeScript representation of this event. But it does not just do that. The log event class is a generic class that exposes methods to decode what's inside the information that I receive, right? Because it's encoded, of course. Next, what we can do is let me copy this information right here, and then I can explain what I'm going to do. But we need to use this file right here, which is, let's close a couple of these. It's here. The project comes with, like I said, with its own code, its logic. It's doing some of these things, but I wanted to expand on the logic, the initial logic, and improve it. So first of all, we need to change the smart contract address that we want to index, and for this, I just need to paste what I just copied. This is the smart contract address of the USDT contract that we can just verify. If you can see, it's F27, ends with 35. If we go back a second and do this, it's mistakes were made, I guess. Let's just fix it. It definitely should be this one. Okay. Nice that I took a double, like a confirmation around. So, like I said, what I wanted to do is I wanted to change this create contract entity that we already have, because this one, it's creating an instance of the contract model, this guy right here, but it's hard coding the information. It's just saying, okay, the contract has this address, and the name is Munsama because we were indexing Munsama in this initial project. But this information is actually available on chain. It's this one. It's right here. The total supply and the name. I think if you go into the contract page and you do read contract like this, you can invoke one of these functions and get the information. Sorry. For example, the symbol. You can also get the name. I wanted to show you how you can do this through the code thanks to Subsquid. And so we're going to copy this, and then I'm going to explain it really quickly. So what this does, there's a couple of errors to fix. We're going to fix it really quickly. It's using this contract API that we have imported from this file right here, because thanks to the API, we don't just have the footprint, the sort of like description of events and functions. We can also, wow, so many functions. We also have this class right here, which is called contract, and it actually exposes the contract functions themselves. And this way I can call them. I can literally just say contract dot name, and it will give me the name. And this is exactly what we're doing right here. So I'm creating an instance of this contract API, and then I'm literally just saying, please give me the name, and I'm saving it into a variable. And then I'm just using the values of these variables to create the instance of the model. What's missing right now, I think, is the next step, which is to fix the part at the bottom, because we have slightly changed how we pass the information around. We are using this context right here, and I'm going to explain in a second where this comes from. it comes from this. This is simply an interface that we use internally, and it's what it basically captures the information that I'm going to receive from the archive. I'm using it to, for example, explore all the blocks that I receive from the archive that contains all of the items that I requested in a single batch. Like I said, it's very important to stress the concept that the communication between the Squid, which is the index that we're building right now, and the archive is in batches. So I'm not going to just receive one single item, one single transaction at a time. I'm going to receive a bunch of them. And if I request different kind of items, I receive them in a mixed way. So I have to sort of do more of this if else logic to recognize them. What kind of item is this one? Oh, it's an EVM log. Then I'm going to process it this way. But I'm getting ahead of myself because actually it's explained right here in the next few steps. So we already have the processor open, so we can fix it by changing this line, because we're no longer importing from the ERC 721 smart contract interface. We're importing from the USDT. We don't need the token anymore, so we can fix it. Actually, let me just not do this. We can fix it this way. So thanks to VS Code, I can just change every time this is mentioned, and makes my life easier. Okay. So, okay. Why is this complaining? Oh, yeah, because I forgot to import. Yeah. So now that I have changed this to be exported, it's possible to import it in this file. Typescript. So then we need to configure how we want our indexer, our processor, to act. And the way we do it, there's a section at the top of the file, which I'm going to show you in a second, that essentially does this. It creates an instance of this processor, which is in charge of the communication between the indexer, the Squid, and the archive, and I can configure it. I can tell it, for example, what's the data source is going to be, and in this case, I want to look up the Moonbeam archive, and I'm also going to specify the Moonbeam like an RPC node of an RPC endpoint of a node on the Moonbeam network. So let's copy this, probably just this, and change this. Like I said, I'm changing this because previously the project was configured to index Moonriver instead. So we don't want that. Next, yes, let's do this, and then I also explain what I'm doing. One more thing that I wanted to mention is this part where I'm configuring the processor. Like I said, I'm telling it where to get the data from, but I'm also specifying what kind of data I want. And in this case, I want to request, like when I'm doing add, I'm basically adding items to the request that I'm making to the archive. And in this case, I'm adding an EVM log. I'm adding the EVM log from the smart contract that I specified in this other file, which is the USDT. And I'm also filtering. I don't want everything that happens with that smart contract. I only want the transfers. We're going to add some more, but first of all, I need to change this interface. And let me first do it, and then I explain where it is being used. This has to do with the fact that we treat data in batches, right? So I need a data interface yeah, it's going to be clear in a second. Just give me a moment to go through the fixes. And then the other thing that I want to do is because we changed the contract, ERC 721 and USDT or any ERC20 token have a different sort of signature for how the transfer event, for its own transfer event. And so I need to do this, and I need to change it because previously we were, like I said, we were indexing NFT transfers. Like you can see here, He was previously using ERC 721 like this, right? And the transfer event doesn't have, like, it's telling me who exchanged it, who received the token, but then it's specifying the token ID, right? Because NFTs have this property where they are non-fungible. Every token has its own ID, its own representation, because they're different from each other. In the case of tokens, like financial tokens, they don't have this property, so I'm only interested in the value, actually. And so what I can do is I can substitute it with this, because I'm seeing how much has been exchanged, and I also want to store it this way. This is why I changed the transfer data interface, because it's being used like this. I'm using this handle transfer to, well, handle the transfer like the function name says, and I'm storing the data in a data interface to preserve the typings. Because I've strongly defined the types in here, I'm making sure that if I, for example, try and add a string in here, it's not going to be happy, because it's telling me you're trying to put a string into a number, and this simply doesn't work, right? And then let's look at where does this information go. The handle transfer function is invoked in here. And as you can see, it's being kept in a variable and added to this array. Why am I doing this? Why am I doing all of this? Once again, this goes back to the batch processing. Whenever, when I launch the processor, after I configured it, the run function simply just goes and starts the communication back and forth with the archive, and it's receiving bundles, batches of information from it, stored in the context. And what I do in this body of in the body of this function, I'm looping over all of the blocks that contain certain number of items. So I'm looping over the items as well. And then I'm checking, is this item what I really want? It's an EVM log? Yes. Then let me try and handle it. Let me try and decode it. Once I decode it, I know I have the information, I store it. And this is a performance improvement. I could save on the database here, one item at a time, but I would lose a lot of performance. So instead of what I'm doing, I'm saving all of the information in an array in memory for the moment. And when I finish processing all of the items in the batch, I save them all at once. This is very helpful. It helps a lot in the performance, and it just granted us a major boost. We're able to achieve like 50,000 blocks per second compared to previous generation and similar other tools that don't do this, which only maybe get to 1,000 or less. Moving on, yes, this is where we also this is where we do the combination of EVM and Substrate, because so far we only we only configure the processor to index EVM stuff, EVM data. With this, we are telling it to request information for an event, which is a Substrate event, and it's the same event we explored in here. The same event we wanted to get the information from the archive. And then we need to make changes in here, because of course now the kind of items that we received, we are going to receive from the archive is going to be mixed. It can be either an EVM log or a Substrate event. We don't know. And this is exactly what this code snippet does. By doing this, I'm telling it, so if the item is not an EVM log, but it's a balance transfer, I'm going to use the class that we saw earlier, this one, right? The one that had the runtime versions, etc. We're going to use that one to extract the event and to check what runtime version wrote the event that I'm looking at. Because as we go through the blockchain, we explore block by block, right? A certain event can be can be written with a certain runtime version, or like if I get to a later point in the blockchain history, it could have been written with a subsequent version, right? It could have been written on version 900, or if you wait a little bit, it could have been written with version 1201. And so we have to adapt and we have to check. Right, that's it. And then we do the same thing. We add the data. We create an interface, an object, right, that has the same shape of that interface that we saw earlier, and we add it to the array, just like this. I need to do a couple of imports. These are libraries that the SDK exposes as well. It's simply converting an unsigned integer array to a hexadecimal string. And in this case, this is a nice ethers library that does the double checking. It makes sure that the address is legit. It's written in the right format essentially. What do we have next? Yes, I think, yeah. So this is where we can go to the save transfers function, this one that does, well, the saving to the database. And we can take a look at the logic. First of all, I need to clean it up because it has mentions of tokens, which we no longer care for. And so we don't know this, we don't care about this, I think. And we also don't care about this. Okay. So let's go through it 1 second. It still has error, but we're going to fix them really quickly in a moment. So what I'm doing here is, once again, it's a bit of a time saver / performance enhancer. I'm creating a set of all of the owners, all of the addresses that I've seen so far, and I'm creating a set, and then I'm checking which one of those are already on the database, and then right here I'm just checking the ones that don't exist. I'm going to create them, and finally I'm creating a transaction no matter what, because every time I encounter a transaction, every time I encounter a transfer, it's going to be a new one by definition, right? And then I'm saving them all at the very end. So I'm doing all of this pre-processing, and saving is the very last operation I'm doing. This is where we try and fix all of the issues that we've been having. Let's see, should be good. Hold on. Yeah, I think it's best if I don't copy the 4, and I'm just doing this. So what I'm doing here, let me double check, is, like I said, I'm checking the owners if they exist. If not, I'm creating them. I'm updating the balance with the 0 because they are new owners. And then because they had a transaction outgoing, I'm subtracting the value. This is, of course, bad math, because the balance transfer is not the only way that one wallet can lose money, right? Or gain money in this case. You can have staking, you can just be, for example, getting rewards, or like there's multiple ways, right? I'm only indexing one, so obviously the math is going to be wrong. One last thing I have to do here is I have to update not the token, but the amount transferred. And I'm doing amount transfer. Oops. Oh, yeah, I forgot this. We're essentially almost done. And no. Okay, now we should be good. Last thing that we need to do is, of course, start the database. Otherwise, we're not going to have a place to store the data. We have a Docker compose file, which is going to start a local Postgres database thanks to Docker. So we can start it like this. And then here we're going to talk about migration. What is a migration? Migration is essentially creating tables for me automatically on the database. We have a default one because it came with a project, and it's going to create certain tables, certain indexes, and whatever. We don't want that. So we have a command to clear any possible existing migration, like this. Migration clean. And then we can create a new one like this. As you can see, we should be able to see it. Yes. It's got different comments in here. These are SQL queries that create and alter the table, etc. And finally, we can start the process. Yep. The second thing that we can do, as I said, a squid comes has this two actions that it accomplishes. It connects to the archive, processes the data, stores it on the database, and then it exposes an API, which is what you want to do. For example, if you want to create a front end for it, like a tab. While we launched this, right, it executed the table, executed the migrations, created a table. But the most important thing is it's telling me, it's logging how many blocks per second it's ingesting, and how many items per second. These are how many transfers and balances transfers that we are sort of indexing and processing at a time. We need a new terminal window to launch the server, the GraphQL server. And as you can see, it's telling us it's listening on this port. So what we can do is we can open this, and let's zoom in. These are queries derived from the schema automatically for us. So because I defined a transfers entity, I can take a look at the transfers, right? By simply flagging stuff. I don't know how many of you are familiar with GraphQL, but this is how it works. I'm creating a request towards the server, and I'm specifying what I want from it by just simply editing this field. It's always better when you do this to create a limit. Otherwise, you're going to request them all, and of course, the server is not going to be happy. As you can see, we have some Glimmer moved. I'm trying to see if there's any USDT, but what I can do is I can filter it down. So I can say where the amount of USDT is greater than 0. That's greater than 1. As you can see, we have some USDT transfers. And this is just the strength of what we just did, right? I'm able to query for a specific sort of a specific thing, a specific thing that happened on the blockchain, the amount of USD transfers. And I have the power of GraphQL to filter it down even more than I could otherwise. I think this is the end of the presentation. What you can do with it, right? As I showed you, you can pick any contract and index it however you want to. It gives you the SDK gives you the flexibility. Basically, the archive ingests the data, the blocks actually extract the data in a way that you can then decide what you want to do with it. As I mentioned, the SDK is in this repository. So if you want to take a look at the evolution of the project, you can just start it and follow it. I don't know how much time we have left. Sorry, yeah, kind of 5 minutes. But like I said, I generate content not just for entertainment, but for education purposes on Medium and YouTube. And the most important thing if you want to grow and learn is the docs, of course. We have a Discord server and a Telegram group that you can join to ask questions. I'm mostly there all the time to help fellow devs. And that's pretty much it. I had a bonus, but I'm not sure if it is better to do this or just answer any questions. I'm trying to read the chat. I see that automated Is that automated ABI code with TypeScript similar to the way Hardhat does it with ABI for typechain? I think so. And for local testing, I do have a tutorial on how to use indexing, Subsquid indexing on a local dev node. So for example, you can just substitute your the chain node with your hardhat node, and you can launch a Dockerized version of the one of our archives, and it's going to ingest data from your hardhat or even Ganesh or whatever you prefer, and it can essentially swap these two. Let me actually share the screen really quickly. This is the latest blog entry that I made, and I just wanted to show the exact piece of code where the change is needed. Yeah, so let's zoom in. So if you launch a Dockerized archive, it's going to expose its API at this address, and you can just substitute. 8545 is the standard port for Hardhat. So by doing this, you're essentially indexing your local node.
Yeah, I think we have a few more questions in the questions tab as well.
Oh, yeah, I didn't see. Nice. Okay.
No problem. So
are the slides? Yes.
Yeah.
So the slides are available at the repository. So the repository, yeah, of course, is not ideal because it's kind of like a loop where I put the repositories. Sorry, like the presentation in the repository, and in the presentation I mentioned the repository. So, but I can post on the chat. This is the repository that I use in the presentation, and in the assets folder, there's a presentation in MD format, and there's the HTML that I just used. Then what else? Oh yeah, you can apply. I forgot what the requirements are needed. The requirements are simply Node.js and Docker. Because you have Node.js, you can just take a look at the documentation and install the command line tool. It's just it's an npm library. So by having Node.js, you should be fine. In the case that the ABI are not available, can we still index the contract? That's a good question, and it's a tricky one because I know personally, for example, I had to obtain the sort of like the ABI in a different way. Like for example, there's some projects which don't upload the contract on chain. That makes it hard. Yes. You might want to contact the project directly if you have access to, like, most of the sort of like the most common one, the most notorious ones do have the contract uploaded there, so it's easy to see the API. If they don't, it kind of depends on the contract. If you find them as a token, you can probably use the ERC721, ERC20, like the standards essentially. If not, yeah, that's going to be an issue.
I think there was just one more that came in at the top. If you scroll up again.
Oh, giant squid. Okay. Yeah, I mean, thank you. That's a good assist. So what is giant squid for the audience? It's our attempt to create one single API to answer the most common questions. I showed you how you can customize, use the SDK to customize it and create your own indexer because you maybe only care about one contract or another and want to do some certain permutations to it. But if you just simply want to know, like, okay, what happened with this contract and this other, you don't want to create various squids, you can just use the giant squid, which is a multi-chain endpoint that aggregates data from, like I said, multiple chains. Currently, I think we have 7 or 8 parachains, but it's just going to expand. And the purpose of it is to help the Polkadot community by serving it this way, providing ready-to-be-used data. And it's also being developed in conjunction with an open source explorer, which is called Calamar. Of course, we keep the pun of ocean animals going. And it's built on top of Giant Squid. So you can explore blocks and events and extrinsic, whatever any common you expect from any block explorer, it's doing it, and it's being powered by Giant Squid. And about the potentials, like essentially endless. You can also it's an open source project, so it has its own repository. If you want a certain feature added, you can just do it. You can just create an issue there.
Awesome. I think that is all of our questions. Cool.
Yeah.
Awesome. Thank you so much, Massimo, for talking.
Thank you.
All of amazing.
Thank you for having us. Thank you for having me. And good luck to all of the developers out there in the chat that's gonna be enrolled in your course.
Mm-hmm.
Keep building. It's what we need right now, I think.
Absolutely. Yeah, absolutely. Awesome. So a few things of admin announcements from me, very, very brief. We do have the Polkadot Hackathon coming up, so please do sign up here so that you can put everything you've learned to the test. Here we go. We do have some prizes to be announcing soon. They are very exciting. So sign up first, and then you'll get all. Arturo, regarding session recordings, I will be doing the weekly email summary of the sessions throughout the week, so look out for that. I will be sending around the recordings for that. Otherwise, you can find them inside the Discord under the kind of the specific Polkadot Educate channel. Please DM me if you need help with that. We have not officially announced the prizes yet, but they will be coming soon. We've got a couple of partners and at least a few K in the prize tracks, but I will say no more than that. Just stay tuned. And yeah, thank you again so much, Massimo. And I think we will end the event there.
Thank you.
Bye-bye.
Thank you all.
See you
Bye.
guys.
Bye-bye.